This question is about compound R with the molecular formula C6H11BRO. Figure 1 shows the infrared spectrum, Figure 2 the carbon-13, and then Table 3 is the proton NMR. Okay, we've got to use all that information in all three of those diagrams and tables. It's 6 marks. This is kind of screaming at you that this is a leveled response, which means you've got to put a lot more down really for kind of 6 marks. And the best way really is for me to go through what you need to do for each table and then for you to check it against the mark scheme for the leveled response. So, right, let's start with Figure 1. This is the infrared spectra. So now I've got an oxygen in here, which means I could have a carbonyl, I could have an OH in here. The first place I'm looking at really is over here for the OH peaks. And there's no OH peaks there for alcohols. It's definitely not a carboxylic acid because obviously I'd have 2 oxygens in there as well. So first thing I need to jot down, and I need to use the data sheet here. So there is no peak between 3,230 to 3,550. Therefore, there is no OH in alcohols. Okay, so remember with infrared, the stuff that isn't there is as important as what the stuff that is there. I do, however, have this peak here. So this is my carbonyl peak. Okay, so and again I need to use the data sheet. So this value here. So what's the value? That's about 1720. So 1720. Therefore, carbonyl peak as it lies between 1680 to 1750. Okay, so that's all I've got from that. I know from the infrared spectroscopy that it is not an alcohol, but it does have a carbonyl. So I'm just going to pop that down here. So it is not an alcohol, but it does have a carbonyl. That's just from Figure 1. Okay, so Figure 2, this is the carbon-13. NMR, and again I'm just looking at things that I've got in here. So I've got a peak at 210. Now again on the data sheet, you've got to quote the data sheet in full. This is a carbonyl, but it's a carbonyl that is in either an aldehyde or a ketone. Remember, you do get carbonyls in carboxylic acid as well. So these are all bits of clues that we're just getting to get all these bits and pieces. My peak at 62, so this peak here, again, just looking on the data sheet, that's carbon that is going to be to a halogenoalkane, and then the peaks at 18 to 42, so the peaks around here, these are telling me that I've got basically alkyl carbons here. Okay, and then the other clue that I've got is that I have 5 peaks, which is equal to 5 carbon environments. Now that's a fairly big clue because I've got 6 carbons here, which means there are 2 identical carbon environments. Okay, so I'm just going to jot all of those bits and pieces down on here as well. So from Figure 2, I know that my carbonyl is an aldehyde or a ketone. I also know that there are 2 carbon environments that are identical. Okay, so proton NMR, that's the one that's going to give me the greatest amount of information. So I'm just going to work my way along this table. and write down everything that I need to do with these. Now you can do your own table in the sheet below, but and I would strongly suggest that you do that. Okay, so I have an integration of 1, so there is 1 proton giving me the signal. On the data sheet, it is that. Okay, and it's a singlet. Therefore, there are no adjacent protons. Okay. So the next one at 3.92. So at 3.92, I've got an integration of 1. So there is 1 proton. Let me just underline that, as that's giving me that. And I know, remember, that there are no, that there are no protons coming off the other side of that. Okay, so at 3.92, I'm looking at 1 proton, so CBRH, so that's what I'm looking at there. So this is the proton giving me the signal. Now it's a quartet, so let me see if I can squash that in here. So quartet, therefore there are 3 adjacent protons. So on here, one of these here, I've got 3 adjacent protons. Okay, so that's that fragment there. Let me draw these fragments down here as I'm kind of doing them. So I've got C double bond O H, and then I've got CBr CH3 with a hydrogen on. Okay, and then at 1.15, so this is in the alkyl region, all right, and there are 3 protons, so 3 protons giving me the signal. It's in the alkyl region, so I'm going to do CH3, that's giving me the signal, so I'm always underlining the ones that are giving me the signal. It's a doublet, so therefore it is adjacent to 1 proton, so CH3 CH, so CH3 CH, can jot that down here as well, CH3 CH. And then here, so there's a big clue here because I've got an integration of 6. Now you can't get 6 protons, so this is screaming at me that I've got 2 CH3s. So and that kind of links back to this bit over here as well. So I've got two CH3s. Okay, so there's my environment that is equivalent. It's a singlet, so it is adjacent to no protons. Let me draw that one here. So CH3, C, CH3, and there can be no protons on there. So let me draw that one down here as well. Okay, so I've got all my kind of bits and pieces here, and it's quite easy to see what's at the beginning and the end of a molecule, whichever way you want to draw it, because I've got 1 spare bond here, 1 spare bond there, so that's the beginning and the end. Okay, so let me put I'll put the aldehyde over here, and I'll put the CH3, so CH3 carbon Br, and then I've got a hydrogen on there, so I've got to put basically this and this in the middle of here. Now there are some things that we can pick out here, because the CH3Br that I've got there is this CH3CBr here, and what that tells me is that, if you remember, there are no hydrogens coming off here or here. Okay, so I'm going to put my carbon in there, so that carbon has got to be this carbon here with a CH3 up there, a CH3 down here, and then that is going to join all the way to here. So it looks a little bit clunky, But there is the final structure that we have there. Okay, so it's up to you really. Look through the mark scheme and see, you know, how many you've hit out of all the things that I've gone through, and then make your judgment as to where you are on that ladder.